Hi, so today I'm going to present my favorite part of the brain, the habenula. So where is the habenula in the brain? The habenula is part of the epithalamus, which connects the limbic system to other parts of the brain. The epithalamus is located in the midbrain and is made up of the habenula and the pineal body. There is also a lateral and a medial habenula, and the habenula projects to the interpeduncular nucleus and other pyramidine cell groups of the midbrain tegmentum. There's a medial and a lateral, as I said, and the lateral plays a key role in learning to inhibit distinct responses to specific stimuli, and the medial is divided into two subnuclei. So what is it involved in? So it's involved in sleep-wake cycles, so your circadian rhythm, emotional related behaviors such as anxiety or depression or fear, reproductive behavior such as arousal, responses to stress such as that deer in the headlights look, learning, and pain processing. So why is it so special? It's a critical crossroad that influences the brain's response to the external stimuli listed. So this is a crossroad that influences the reaction of external stimuli on the brain, such as freezing up during a play on stage due to stress. Now, the lateral habenula is established in pathogenesis of major depressive disorder, and it modulates acetylcholine. And acetylcholine coordinates for firing groups of neurons within the brain. Now, the medial habenula modulates serotonin levels, which are responsible for your mood. So if you're having low serotonin levels, then you're more likely to have depression and anxiety. And it also releases norepinephrine, which increases anxiety and arousal. Sleep-wake cycles. So the neurons fired from the habenula display circadian rhythm, which is when we wake up versus when we go to sleep. And it also plays a crucial role in our REM sleep regulation. So REM sleep is the sleep needed during nighttime where your eyes are rapidly moving and your brain is essentially processing everything throughout the day. Now, without this REM and circadian rhythm during sleep, one can suffer from sleep disorders. So, a common one, if your circadian rhythm is off, could be like insomnia or any other of the insomnia related disorders. Function and pain processing. So hyperactivity of the habenula is seen in individuals with major depressive order and when people fail to complete a task. So this task could be done by someone who doesn't have depression and they would still experience hyperactivity in habenula. So say someone is trying their best to learn how to complete a new task, such as riding a bike, and they get frustrated and they fall over and they keep trying and trying, they're going to have hyperactivity in the habenula as a result of this. And the part of the habenula that is responsible is the lateral, and the lateral habenula actually responds to all negative stimuli. Now, the behavioral response to stress. So stress and aversive events induce the lateral habenula. And when the lateral habenula is activated, this causes someone to freeze up or the deer in the headlights look, which I included a cute little clip of, wow, you look like Kushner caught in the headlights, because this deer is experiencing a flare-up in their habenula. So this can also happen during stage fright, and this response is a decrease or cessation of motor activity. So the deer is frozen and it's not moving anymore because of the stressful event of seeing a car, such as the car in the headlights. Learning involvement. So the habenula is activated in reversal learning tasks and learning processing. So these correspond to behavioral responses to predicted error signals, and it's particularly strong when associating reward with an already learned task, and then when the individual is no longer receiving that reward that they were already receiving. So a study was done with Yoshina et al. That I thought was super cool. When I was looking up pictures and doing my presentation, I found this study, and it found that the habenula is particularly important in aversive prediction errors, which are elicited by reversal learning tasks. So this demonstrates that there's a possible involvement of the habenula in conditioning. So in this experiment, monkeys were given a certain task that they had to do step by step, and then by the end of the task they were rewarded, and after being rewarded several different times, they then stopped rewarding the monkeys with this whatever reward that they were giving, and then this elicited a behavioral response from the monkeys. Now I have a few personal connections I would like to add as to why this is my favorite part of the brain. Now, the habenula is my favorite because it involves a lot of sleep, and sleep is something I have struggled with throughout my entire life. So it's involved in the circadian rhythm, as we mentioned, and REM sleep. And then I experienced personally some night terrors due to a car accident at birth. And this was super controversial between my doctors because to them, they didn't think that I was functional enough to actually remember what happened. But I personally think that's why I have night terrors. Anyways, so when we were in deep NREM sleep is when the night terrors occur. However, to avoid these night terrors, I did a sleep pattern of naps. So I would come home from school and I would nap for 3-4 hours, get up, do some homework, go back to bed for maybe 2 hours, and just keep going and going. So I found out that napping harms your circadian rhythm, and that there was a time when naps are my primary form of sleep, and then because of this, my circadian rhythm was completely off and has been completely off for a while. And now I'm getting into the routine of sleeping at a certain time and getting up at a certain time, and hopefully getting that back into rhythm, because now I don't experience those night terrors. And then I linked the reference to the study that I found that I thought was cool. And otherwise, I used SunGage and materials from the course to make this presentation.